Hello everyone. This is a start of a new series where we'll be interviewing some researchers who are doing their research in the present cutting edge community, like from different areas, like from physics and also from the mathematical physics community. So today we have with us Mostafa Sabri. He is from NYU Abu Dhabi. So we'll talking about him, like about his research and about what motivated him to do research. So yeah. Hi Mustafa.
Hello.
Nice to meet you.
Nice to meet you.
So can you tell me like something about from your childhood or school days, like what motivated you to do your research in this maths field, on what inspired you to be a mathematician, basically?
No, actually, when I was a kid, I was not really interested in mathematics. So I was more interested in sciences and biology, things like this. But I only start. I think so. My grades were good in math, but I didn't really. I was not interested in it. But at least the way math is taught in elementary school is very bad. I think it's not at all about mathematics. It's about calculations and so on.
Formulas and all.
But then by the end of high school, I learned a bit of calculus. It started to get a bit more interesting, I guess. And then as a freshman, when I went to the university, I went to the science university, and I had in mind to do genetics actually.
Genetics.
Yeah, but specialize in that. So first do some biological training to lead to that. And at the time, the Human Genome Project and these kind of things were a hot topic. So I thought it would be nice. But then when I took a course as a freshman of mandatory calculus, it was very good. And my professors at the time really urged me to do math instead. So I was also interested in physics, and I had no idea what can be a career in math. So I decided to do a double major in math and physics. And as the years went by, it was very clear that I was a lot more interested in math than in physics. So when I did my master in France, I did a master in math, and then PhD, and then postdocs, and so on.
And regarding you, you were yesterday telling something about then when you were doing your PhD, there was what was your PhD topic, basically thesis on?
So it was in mathematical physics actually. So it was about the Anderson model, about localization on metric graphs, or quantum graph if you want. So it was multi-particle in principle, but a finite number of particles. So I don't know if this is really physical or just cheating, but it's all we can do currently in math. So for Schrödinger operators, so it's not a positive density of particle, it's just maybe 5 particles or something like this, a finite number which does not grow with size. So that was the topic of my thesis on eigenvalue concentration and so on. Then in my postdoc, I did something very different.
Who was your postdoc advisor?
So my postdoc advisor was Nalini Anantaraman in France, and so with her I worked instead in the regime of delocalization. So trying instead to prove that, let's say for the Anderson model, if the perturbation is very small, then actually everything is delocalized. So I think in the physics community this is obvious, but in the math community this is one of the most important open problem of mathematical physics in ZD. So what we did, we essentially solved the problem in trees. So in the case of trees, it was known that somehow the spectrum is smooth if you want, you have absolutely continuous spectrum, but we showed that actually the wave functions are also very delocalized, which I think is the more important thing, that the eigenfunctions are really spread out. So technically we have a quantum ergodicity theory.
Yeah. And it was a special anecdote that you told yesterday that after your PhD you wanted to go to Egypt and become a lecturer, but somehow.
So at the end of my PhD, due to various reasons, partly I was kind of depleted, let's say. So I was exhausted, and even actually before the end of my PhD. So by my last time, I was pretty tired, and I was starting to lose interest in research somehow. It's also the community with which you do research really plays a role. If it's a nice community, is it not? Are you isolated? Things like this. So anyway, I thought maybe I was not really interested in anything. So I thought maybe at the end, after my PhD, I'll take a position in Egypt, where I did my undergraduate studies. To be so there you can be an assistant professor if you just have your PhD and you were in the system before you traveled. So before I went to France for my master and PhD, I was an undergraduate there, and I had the best grades, so I was already somehow in the system. And in this case, you can go back to be an assistant professor. And that's basically what I did as soon as I finished my PhD. But then my PhD advisor somehow urged me to continue doing research. So the next year, I went back to France to do this postdoc with Nalini, and it was very good.
Okay, nice. So, in your current NYU Abu Dhabi, so what is the main focus right now?
Main focus of what?
Quantum ergodicity.
Yeah, research. You mean?
Yeah, research.
My current research. Yeah, so in my current research, I'm following these things of delocalization, but from many aspects now. So not just at the level of eigenvectors, also at the level of dynamics, at the level of the spectrum. I'm trying now to understand a bit more broadly how it works, and not just on trees, but on different structures as well. So what we did recently with Theo Mackenzie, for example, is this quantum ergodicity, but on periodic crystals, which I think may be more physical. But unfortunately, it doesn't include the Anderson model. So as I said, the Anderson model in Euclidean space is completely open in the mathematical community if you want delocalization. And that's what I'm trying to understand better. But so I thought that maybe as a first step, I understand better the periodic case, and perhaps we'll find other models for which we can say something. And so I'm always interested in problems which are at the interface of math and physics. So I'm not really interested in just doing math for math itself.
For the physics point of view.
But I always publish in mathematical journals. So I've never published in a physical journal, but at least I need some kind of physical motivation.
Yeah. So it was nice talking to you.
Thank you.
And all the best for your future. Okay, thank you. Thank you so much.